Assalamu alaikum students. Before starting exercise 10.3 of mathematical methods, you must know about the UC method, that is the undetermined coefficient method. In UC method, we find the general solution, and in that general solution we need the complementary solution and particular solution. You already know very well how to find the complementary solution in exercise 10.1 as well and 10.2 as well. We did it already in exercise 10.1 of mathematical method. To find the particular solution, you need to focus on the non-homogeneous part, that is f of x of your given differential equation. In your given differential equation, whatever your f of x is, you have to observe what kind of function non-homogeneous part you have, and then according to that f of x, you have to find your particular solution. Now, what is this f of x? For example, you are given with some kind of question like this: y the second derivative plus 2 first derivative of y plus y is equals to ex cos of x. This e of x cos of x is the non-homogeneous part, and that is your f of x. So you have to observe your f of x, and according to that f of x, you have to write your particular solution. If your f of x is some constant like 3, 4, 5, 6, anything, then your yp of x is going to be xk some constant a. If your f of x is some kind of depending on x that is having some power like x square, x4, like that. For example, you have, let's say, ax cube. Then we are going to write it this way: xk a naught x cube, this highest power, plus a1 x square, 1 power less than 3, plus a2 x, and plus a3, like this in descending powers. And if you have a polynomial combination of terms, then how we're going to write it? We're going to write xk. Every time we have to write xk with them. Xk a naught plus a1x plus a2x square plus up to until the highest power you have here, an xn. And if, for example, you have some power of x and you have some exponential e raised to power ax, we have to write xk as usual, always, e raised to power ax, same as it is, and then this xn will be written the same way we have written this thing. That is a naught xn plus a1 xn minus 1 powers less than. Powers are decreasing. Plus until an. And if, for example, you just have e raised to power ax, then you are going to write xk e raised to power ax. And if you have the powers of x and some trigonometric function cos ax, then we are going to write xk as it is, a cos ax plus b sine of ax. And if we have, like, for example, sine ax slash cos ax, and there's no power of x here, then we will write xk a1 cos ax plus a2 sine of ax. And if you have, for example, eax, some polynomials are adding up here, sine ax plus some polynomials and cos bx again, then we are going to write it xk bracket sine ax plus bracket cos bx. Now look at these. This is the same as this one, so you have to write this thing. This one is same as this one, so you have to write it. So it's a naught plus a1x plus until an xn, and same thing here, a naught plus a1x plus until an xn. I hope you are clear how to write the particular solution. Once you got the particular solution, for example, you have some kind of differential equation like this. They have given you to solve this: y double prime plus 2y prime plus y equals to ex cos of x. This is basically second derivative, d2y by dx square plus 2 dy by dx plus y equals to ex cos of x. This is question number 4 of exercise 10.3. For example, they have asked you to solve this by UC method of undetermined coefficient. First of all, you have to do what? You have to find the complementary solution. For complementary solution, to find YC, to find the complementary solution, you have to write the associated equation. M square plus 2m plus 1 equals to 0. Write it as 0, the homogeneous equation. Factorize it. Once we factorize it, we will get here m equals to -1 and -1. You can factorize it. You can find the roots by using the quadratic formula. It's up to you. These are repeated real roots. So how we are going to write the complementary solution? It's going to be c1 plus c2x e raised to power minus x like this. Or you can also write c1 e minus x plus c2x e minus x. Mark this one as equation 1 and mark this as equation 2. Now to find the yp, that is your particular solution, we are going to use the UC method here. And we are going to follow the same thing I showed you here. So, you know that your f of x is ex cos of x. So, yp is going to be xk ex. And you know that when you have cos or sine, we are going to write here a1 cos x plus a2 sine of x. Now we have to take some value of k. K can be 0, 1, 2, 3 and so on. This is according to your differential equation. On which value of k it's going to satisfy. I am taking here k equals to 0. On k equals to 0, your particular solution is reduced to x raised to power 0. That is going to be 1 obviously. So it's going to be ex a1 cos of x plus a2 sine of x, because you can see that there is no x here. So to finish this x, you are taking the k is equals to 0. This is your equation 3. Now, equation 3 is the solution of your equation 1. So it must satisfy the left and right side. So our main purpose is right now to find a1 and a2. And how we are going to find out? We are going to substitute this y in this equation. We need its second derivative, we need its first derivative, and we need it as it is. So let's find its first derivative, dy by dx. So you can see that ex is multiplying with this. We are going to use the product rule here. So first of all, ex as it is, and let's find the derivative of this bracket. It's going to be negative a1 sine x plus a2 cos x. Now plus this bracket as it is and take the derivative of ex, that is ex a1 cos x plus a2 sine of x. And just simplify it. You can simplify it like this. Ex, take ex common. a2 minus a1 take sine x common plus a2 plus a1 cos of x like this. Now again find its derivative because we need its second derivative as well. So it's d2y by dx square of your particular solution. Derivative of this thing. Again you are going to use the product rule between ex and this complete bracket. So I am going to write up here the final answer. That is going to be 2ex a2 cos of x minus a1 sine of x. Now we are going to use the value of second derivative, first derivative, yp in this equation, left side of equation number 1. So when I will use these values here, I will get this equation. 2ex a2 cos x minus 2ex a1 sin x plus 2ex a2 minus a1 sin x plus 2ex a2 plus a1 cos of x plus ex a1 cos of x plus ex a2 sin of x equals to ax cos of x. Now we have to rearrange according to sine and cosine. Take all this, combine all the cosine of x together and combine all the sine of x together. If I will combine them all, I will get here ex 4a2 plus 3a1 cos of x plus ex minus 4a1 plus 3a2 sin of x equals to ex cos of x. Now, do you have any sin of x on your right side? No. We can write it this way, plus 0 sin of x. Why? Because I want to compare the coefficients of cosine and sine from left and right side. So comparing the coefficients of cosine x on both sides, I will get here ex. You can say like, okay, let's write ex here as well. If I will compare the coefficients, because you see everything will be multiplied and you will get 0 and this thing same as it is. Now, if I will compare the coefficients of cosine x, I will get ex 4a2 plus 3a1 equals to ex. And if I compare the coefficients of sine x, ex minus 4a1 plus 3a2 equals to ex into 0. I will get here 4a2 plus 3a1 equals to 1. And here I will get minus 4a1 plus 3a2 is equals to 0. Now I am going to solve these equations simultaneously. You can add them or subtract them by multiplying and getting the same coefficients, or you can also solve these two equations by substitution method, any method. So I have solved here by elimination method. You can solve it by any way, and after solving I will get here a1 as 3 over 25 and a2 as 4 over 25. So my particular solution that I found already became ex 3 over 25 cos x plus 4 over 25 sin of x. That particular solution, this one. I'm just plugging in here the a1 and a2 values. After plugging in the values here, I got this particular solution. So your general solution y is yc plus yp. Just add up those two solutions. c1 plus c2x e minus x plus ex over 25. And here 3 cos of x plus 4 sin of x, like this. So this is your general solution you got here by using the UC method. I hope you understand. For more examples, I will upload exercise 10.3 questions, and you can see it. You can observe that how we are going to apply all the UC method by P's there.